Hello, Pascal.
Hey, Utpal, how are you?
Yeah, fine. So it's 2, right? So
Yes, we should start soon. Do you want to do the introduction?
oh, it's okay. I mean, nothing to talk about this today's introduction because all the participants basically they were present yesterday's session. So if you want to add something for today's speakers, then straight away we can go to the speeches.
Utpal and Pascal, I'm sorry to interrupt. I'm Shivani from the tech team.
Sure.
Yes, so before we begin, we would request everyone to start their cameras and we can quickly take a group picture.
Okay, a group picture. Okay. Let me find. Okay. Wait, I'm struggling with my different screens. Now here, that's much better. Yeah, so everybody should turn on their camera and do the group picture.
Yes, we can go on to the gallery view and we can take the group picture. I'm doing it as well from my end.
We're not at our most numerous right now, but that's okay, I suppose. So Parag and Pierre, if you can, okay, Parag, great. Pierre, if you can turn on your camera. Great. Okay, so Shivani, are you taking care of the photo?
Yes, give me a moment, please.
Sure.
Yes, perfect. Utpal and Pascal, we can begin with the workshop now. Thank you so much. All the very best.
Thank you. Okay. So yes, like as Utpal said, we don't need an introduction, so we can start right away and almost on time. So the first speaker this afternoon then is Pascal Neveu from INRAE in Montpellier on
Yes.
AI methodologies and big data.
Okay. I will share my screen.
Yeah.
Can you see my screen?
Yeah, perfect.
Thank you. Hello, everybody. The title of my presentation is Overview on Artificial Intelligence Methodologies and Big Data for Agriculture. And I am Pascal Neveu from the National Research Institute of Agriculture and Environment. And I am working in MISTI Research Unit. And MISTI Research Unit is we want to develop mathematical, statistical, and computer science method for agriculture challenges, such as food security or adaptation to global change. And for application, more precisely, or plant phenomics, for example, for food security, agroecology, precision agriculture, animal welfare, or food processing. But all these applications, we always take into account the environmental interaction. And also, what we develop methods that are interpretable, so, because we want to have a specific focus on understanding and also for decision support. As all of us know, agriculture data are complex because we have different scales, different interaction between scales, different stage, different contexts, different disciplines. For example, you have socioeconomic data, genomics data, environmental data. You need to have soil data, climate data, etc. And the question is how this complex data, this big data, can help the agriculture sectors. And of course, often data has no value. Data is only valuable if it can be grouped. And if you can group data in different ways, you can give value to your data. But currently, too much data, you have too much data silos. And agriculture data needs structure adapted to this complexity. That will be the first part of my presentation. But before, I will say some words about artificial intelligence. Artificial intelligence refers to computer systems able performing tasks that normally require intelligence. And for example, you make AI also is a name given to algorithms that produce intelligent action. And of course, we saw yesterday there is machine learning, there is different approach, but not only, you have also the knowledge engineering that based on knowledge representation formalism, and after you can apply logics and reasoning for infer new knowledge or new data, new information. And also another way, it could be, for example, for constraint programming. You can explore and evaluate a large number of possibilities in order to have, for example, a good propose a good result or the best result or good decisions or something like that. There is different ways, and not only the machine learning. And artificial intelligence can be used in many different ways for agriculture. For example, you can use knowledge graph in order to deal with and take into account a large number of parameters and various data sources. For example, if you want to exploit IoT of agriculture, or if you want to develop applications that go from farm to fork, you can use constraints programming in order to make choice, look for the best or good solution, for example, to reduce environmental impact. And as we saw yesterday, we can use machine learning for make recommendation, decision support, reasoning, extract knowledge, etc. And deep learning in order to use, to recognize, identify objects, diagnose, and for example, for early detection of diseases. And the convergence of big data and artificial intelligence, it's AI needs a lot of data, but data must be structured to benefit to AI algorithm. And for that is very important to apply the fair data management in order to make data findable, accessible, etc. And what I will present now is the first work in my team, that we structure data in knowledge graph. The idea is to use metadata ontologies in order to provide the meaning of data and the context, and that allow to link each data element with a controlled and shared vocabulary that can be interpreted by machine. So it is the idea, but we structured data in a graph. Here you have some information about different things, but it's very hard to find what is exactly. You can see that I have a concept at maize or things like that. But if I have semantics, and if I put the organization, the structuration in the graph, I will be able to extract knowledge, to make reasoning, to infer new information. And for that, we use standardized language such as RDF, RDFS, or OL is an ontology-weighted language. And the product that we developed is called OpenSilex, and we have also worked on AgroPortal. AgroPortal is an ontology repository, and the idea is the high part of this is sample extraction of a model is to deal with information and be able to have reasoning. For example, here in red, you can infer information. But the idea is to use graph in order to reason and to have something intelligent with data. But ontology structured data under the object of agriculture, IoT, for example, or object of plant phenomics, and that allow also to discover knowledge. And instead to explore in traditional way, we explore tables, but tables are not so adapted to discover knowledge. I will show you some example of use of graph. The first one is an algorithm that automatically learns to discriminate a resource. The resource could be a plant, a product, etc. in heterogeneous data set. And the idea is to use key in order to interpret numerical data in symbolic way. And we will construct key. Key is a set of variables that allow to uniquely identify individuals. For example, for human, this could be fingerprint, or it could be the distance between your eyes or mouths, etc., that allow to discriminate individuals. And for that, we are able to recognize subset of discriminating, for example, aromas compound, and for wines. And we develop a tool that recognize automatically the fingerprint on thousands of wines, and then after allow to discover links between aromatic profile and environmental condition. But we can do for discover plant phenotype characterization on various environment for many plants. Could be for rice, could be for wheat, etc. This I will go fast on this this part because was very close that we saw yesterday. But we extract the number of leaves of plant, and after we use convolutional neural network and feed-forward neural network for counting the number. So except we have many photos, and we start training with human access from plant. I will show you, for example, another part of our work. It's a rule discovery based on frequent item set extraction. The idea is to have instance. You have instance of different classes. For example, plants, insects, environmental conditions, disease, etc. That we observe on many sites. And the connection between the different classes depend on the number of the common observation. And after, we can generate a graph. And the idea is to cut the graph, and the elements that are frequently together will be discovered, and we can find patterns, we can find strong association in order to help us to, for example, for the design of agro system that respects some rules in agroecology or things like that. I think I must conclude now, but I want to say that there is very stakes and very big challenge on data, such as for IoT of agriculture, for the development of the artificial intelligence. A lot of data exists, but are not often easy or cannot be mobilized. Structuring data in graph, very stable, open new ways for artificial intelligence. And I want to say that in our mind, in our brain, we don't have tables, we have something that's graph. And I think we must develop the graph approach for machine learning. Challenge of agriculture are strongly multidisciplinary. For example, we have biologists, we need geneticians, people from different domains. And artificial intelligence can also support the integration of various skills. Thank you for your attention. If you have questions or remarks, complement.
Thank you very much. I think, like yesterday, we're going to keep the question after the second talk of
okay, wait, yes, sorry, I forgot.
Not a problem at all. So we can switch to our next speaker, who's Kamlesh Narayan Singh, and who will be speaking of applications of ML techniques for crop yield forecasting. using more, I guess, than just pictures, just image analysis.
Okay, good morning, my Indian friends, and good morning to French friends. I'm going to speak on application of machine learning techniques for crop yield forecasting using weather variables. Before I'm going to detail, just because yesterday I could not introduce myself, so I am Dr. Kamlesh Narayan Singh, working as a head of division forecasting and agriculture system modeling at IASRI New Delhi. So actually started, Dr. Alka Arora has already briefly introduced the institute, and I am looking after forecasting agriculture system modeling. So we are working on the forecasting of crop yield. This is my team, because you mentioned that the team is working. So here I would like to mention that India is a very vast and diverse country. We have different climatic zones, culture and other things. We are having diverse crop also. And forecasting of this food grain production for the country is very important for the planners to the country. So for that, government has set up a center, that's Malnourished National Research Crop Forecast Center. And we are developing the forecasting models to get the advanced forecast of food grain production of the country. And here, what we are doing, we are using the weather variables to forecast the crop yield, because there are many, important factors to forecast the crop yield. But for the, developing models for whole of country, a single model, it is a very difficult task. So what we are doing, that district wise or block wise, we are developing forecast model for all the major food crops. And what we are doing, that since ISRI is working under Fasal project since 1980 onwards. So what we have done, that Hendrick and Stoll and R.A. Fisher was first to introduce this type of model where weather variable has been used to forecast the crop yield. At ISRI, we have modified this weather-based model into this type of model. And here we have developed the weather indices. That's a ZIJ is something like, it is the combination of correlation coefficient and weather variables. These are defined here, where RIW is the correlation coefficient of yield with ith weather variable and in the WH period. And this is RII-W is the correlation coefficient of yield with product of ith and ith weather variable. M is the period of forecast. So for example, if you are interested to forecast the crop, wheat crop before harvest, so this model can give forecast before any, period. Period of forecast is the standard meteorological week. P is the number of variables. E is the random error. Here E is the random error. Earlier we have used that this error is normally distributed, because considering this errors are homogeneous. But since event of this machine learning techniques and other advanced techniques, this assumptions is now no more relevant. So you can see here that these are the weather indices. See, if suppose you are having weather parameters, you are having many independent variables here. So there was problem of dimensionality. This number of parameters are more than number of observations. So here, initially ISRI has recommended stepwise regression method, where using stepwise regression method, we have selected the important variables, and those important variables has been used in this model to give the forecast. Later on, when I joined this institute, we propagated that if instead of stepwise regression, if you use lasso techniques, the result will be better. And we have proved by simulation techniques and other techniques that lasso is performing better than stepwise regression when we are using this lasso techniques for the selection of independent variables. Because here everybody is expert in the machine learning techniques, so I am not going detail in the lasso techniques. And recently we have used that random forest also for the selection of variables, and we have found that in many places, if you are using random forest for the selection of variables, that is performing better than any other variables, including lasso variables. I have written some thing about the lasso techniques where we are minimizing this factor subject to some constraints. And here in random forest, we are minimizing this out of bag. And this is the function we are minimizing. In actually, and in this, we have used the support vector machine also. Here, this is the function we are minimizing. In support vector, we are using the kernel. I think kernel is a collection of mathematical functions. So there are many functions, and we have got the optimum function for use of forecasting. And we have used 3 data sets. First data sets is for the Medak district of Telangana states. There we have used 29 years data, that is 1988 to 2017 data. This is the number of observation is 29. And in the second data set we have used from Rajasthan, we have used 25.25 observations are there. And third data set we have taken from Jalandhar, Punjab. We have used 40 years data, means 40 observations are there. So what we have done here, each of these data sets had partitioned in 2 parts. We have utilized 90% of data for the fitting of model and 10% data for the validation of results. And these are the results I am going to present. And data source is this IMD Pune GOV, this is government data. And this is the simple plot of the yield. This is the plot of Medak data. You see here constantly yield is increasing. But here if you see in Baran districts, the trend is not in same fashion. And here a lot of heterogeneity is there. So this is the 3 data we have used. And this is the result. What I mentioned that we have used this random forest and lasso technique for the selection of features. We are having more features. When you have used for this Medak district, we find that 4 variables have been selected using random forest and 2 variables using lasso techniques. And in this Baran districts, random forest, we have selected, I mean, it has automatically got selected 5 variables and 5 variables in lasso. So it is not fixed that whatever the system is giving, we are selecting those variables. And in Jalandhar districts, 4 random variables were selected in the model using random forest and 3 using lasso techniques. And this is the result. Those selected variables has been incorporated in the forecast model, what I have given in the previous slides. If you are using this random forest, we have got this, these are the statistics by which we are performing the, their comparative performance. So this is the mean absolute deviation, this is the root mean square error, and this is mean absolute percentage error. Our main concern is mean absolute percentage error. If you see in the district of Medak, random forest and lasso both have performed equally well. I told also that there is not much variation in the data. But if you see, this is the in sample, data, means the data which are fitted for the model. This is the result for that only 90% data. And for the Baran districts, it is saying that this lasso techniques has performed better than this random forest model because the mean absolute percentage error is lesser here. And for this Jalandhar districts, again, statistically, you can say random forest and lasso both have performed equally well. But when we are coming to out of sample forecast, means after 90%, it is out of sample forecast. There, if you, in this Medak district of Telangana, almost both have lasso and random forest has performed equally well. But random forest has performed much better than lasso in the Rajasthan districts. Again, in this Jalandhar districts, this random forest selection of random forest is performing better. And suppose if we are, if directly we have used this random forest regression and support vector regression without going to the selection of, those variables, that also we have tried, and we have seen that if you are using directly this, we are not going for the selection of variables. Directly, if you are applying this random forest or support vector regression, there, if you see random forest is performing better than support vector regression and stepwise regression. And here in other districts, the support vector regression is performing better. And in Jalandhar districts, again, random forest is performing better if you are directly using the regression. And that was for the in sample, this was for the out sample. And the conclusion here is if you are using this our weather indices methodology, and if you are using using weather indices and regression models, when the random forest is used for the selection of variables, and other is directly you are using random forest as a regression model. So it result says if you are using random forest with selection of features, then the result is better. And it is proved in all the districts that if you are using this random forest for the variable selection, and after the selection of variables you are using the regression method, then the result of the forecast is better than directly if you are using these machine learning techniques for as a regression model. So this was the results, and this is the summary of my results only. This is saying that finally the machine learning techniques has been compounded with regression model coupled with feature selection with the help of random forest. This was my main finding. And rest, if any discussion will be there, I will be ready to reply. Thank you, sir.
Thank you. So now we have some time for questions for both Kamlesh and Pascal. So go ahead. Kamlesh, can you stop sharing your screen? Thank you. Utpal?
Yeah, I have one question for Dr. Singh that say, when you analyze results that somewhere random forest is doing better than Lasso or this. So can we go into the deep reason that, so what could be the possible explanation that say sometimes random forest is working better than Lasso or vice versa? I mean, did you get any scope to analyze that?
Thank you for asking this question. Actually, I am also interested to know the answer of this thing, because since many years, we are working on different machine learning techniques. And see, our target is we should give some optimum model for any, forecast model. But till date, not only in India, I could not find any paper in whole world that they says this model is optimum model for whole, inverse you can say. So your question is very pertinent. Right now, I do not have answer that why this Lasso is performing somewhere better and random forest is performing somewhere better. I tried to read those things, but everywhere I found that these are the machine learning techniques, and this is a machine learning technique, and they have their own inbuilt capacity to capture the this trend of the model. So I could not find the correct answer. That's why I joined this workshop, because that is my question also to the people like you, because you people are working really, you are doing that, because our part is the application. Mainly we are working for application part, but I am also interested to work on some optimum property of any model, not only machine learning technique, any model which give the forecast of the country. You may be knowing that this is a very important project of Ministry of Agriculture to give the forecast of the country. So till date, earlier we were using only stepwise regression. Now we are using Lasso techniques that has been adopted by India Meteorological Department. Everywhere we have replaced the stepwise regression to Lasso techniques. This random forest and support vector machine, we are trying to simulate data, or we are trying and mean a large number of data sets. So only doing the analysis on large number of data sets we are recommending, and moreover for each district, whichever model is performing best, that we are recommending that you should use this model to forecast the yield of this particular district. Sir, I am sorry, I cannot answer that why it is like that. If you can help me In any way, sir, I'm really happy to know the answer, sir.
Thank you, Dr. Singh. In fact, yeah. So we, the machine learning community, you know that it's not that easy to answer this. But what I was thinking that say a random forest you are using as a classifier, right? On the other hand, lasso you are using as a regression.
No,
So
sir.
that's why
both cases we are using classification.
Both, right.
Both cases. We are selecting the important variables.
Yeah.
Both cases.
Right. Yeah. So actually, may I request some comments from Pascal Review, because this is a problem. So in agricultural research, is there any trend to find that insight that which model is because you are also using a lot of machine learning models. So some comments from you, Pascal Review, please.
Yes. The two methods. The first one is new one that we develop. Real new approach.
Yes.
And the second one is more classic in data mining. It's a item set methods. But in my lab, we also have statisticians, and we always, for example, we work on lasso, we work on many different aspects, but most of the time for when you have a lot of data, we work on functional data analysis methods, specific method for functional data. Instead to use scalar, we use curve and things like that in order to explain. But if you are interested by some statistical work, we can contact me.
So this goes maybe in the direction that you were saying, that working on tables is one thing, working on data that's structured in graphs,
yes,
offers more possibility. It's more abstract, it's more difficult initially to visualize in some sense, because many more dimensions are taken into consideration, but that's where the ML tools become relevant. So you Pascal, you insisted on the challenge of data. I mean, that is very diverse, heterogeneous, coming from different fields of study, and it's scattered, it's partly structured, so ontologies are important. And this made me think of what was discussed also yesterday of the or the usefulness of sharing that sort of thing. So having repositories, open science sort of repositories for all of this. I mean, for raw data, for structured data, for annotated data, for so do you have some ideas to share about this?
I can say some word about this. First one, for example, we have at the National Research Institute of Agriculture and Environment, we have a specific site that called INRAE data INRAE.fr, and you can find very nice, very great data available for the community. If you don't find the site, you can send me an email again. And another part is we also develop now with we have higher researchers, and we developed an ontology portal that called AgroPortal. And also, if you that allow to improve the data quality and a better description of data, and in order to integrate for machine learning. More you have data, better it is.
So my request is to Dr. Utpal, because he's, I think, the person, I mean, for this main person, I think he is from Indian side. So my consider, because we are working for the government of India. So if Utpal can help us, means government, to improve the model, that will be a very good contribution to this workshop also, sir. If you need any data, I am ready to provide, sir.
Thank you. Thank you. So I have one more just following question with Pascal Review, that so in machine learning, say nowadays, because of the deep learning, this data hungry nature, so there are many models for generating data, right? I think that in agricultural research, you are also using some of the models for data generation synthetically, right? But is there any say technique for validating this, not only statistically? Say, for example, I use say GAN or something, and I can generate some data following the distribution of the real data. But in terms of practical use, is there any way to validate that the quality of the generated data?
The quality of yes, well, the quality of the quality of data or quality of methods?
Quality of the synthetically generated data, because one traditional way that statistically I can compute some distribution and I can show that distribution is very close to the real.
For that, we have a collaboration with Wageningen, with Fred Volnovich. I think you know them, and we have a collaboration in order to have more automatic tools for develop for validating data, because when you have a lot of data, it's very hard. You're right.
Okay. Thank you.
I can send you some.
Okay, great. Yeah.
Package or software package in order to improve that. I can send you some information about this one.
Very good. Edmond, if you have a short question.
Yeah, do you hear me? Hello?
Yes, we can hear you.
Yeah, okay, so just one remark to Dr. Singh and Dr. Pascal Neveu, just to inform them that there is an MOU between INRAE and ICAR, in which we are working on a work plan. So it is already possible to launch, let's say, cooperation between these two eminent searchers on AI, and I could help them to link this cooperation. Thank you.
Thank you so much.
Yeah, so that's relevant for the future of this collaboration. That's great. Okay, so maybe we can switch to the next sequence of two talks. So Parag, you're up. Parag is from the AdaptiveWise Management Consulting Company in Mumbai, and he will tell us about data-driven solutions in agricultural finance.
Yeah, am I audible? Hi, am I audible?
Yeah, we can hear you. We can see the slides.
Okay. Give me a minute. Yeah, so hi, my name is Parag. I'm a product manager with AdaptiveWise Management Consulting Mumbai. This is an agri-fintech startup dealing primarily with agricultural lending, coupled with monitoring of the assets through remote sensing technology. So as a background, I am an agricultural engineer from IIT Kharagpur, and I've also done my master's from ISI Kolkata. So for today's talk, the agenda I would be discussing about is the overview of the problems faced in the agricultural finance and insurance, a 360-degree overview of our solution, how we would be facilitating institutional credit, our areas of work on AI and ML, and certain model outputs which we did for an area analysis on Chandan. It is a village in Jaisalmer for which we did our AI models analysis. So, and lastly would be the potential areas of collaboration at the end of my talk. So when I talk about the problems in agricultural finance and insurance, the major problem faced with smallholder farmers is that they have very less documented assets, and to use it as a collateral is very tedious arrangement for the institutional agencies. Even the institutional agencies face a major problem that since they can't use the collateral against such farmers, they don't have a metric to verify or say assess this farmer based on the credit repayment capabilities. So for them, the cost of lending relative to the size of the loan to these small farmers is itself a challenge. And some of these challenges we think we would be able to answer through analysis of data on remote sensing scale, so that these lending agencies can have insights into which areas to operate and how to disburse their loans. The second problem is of overdues and default rate. Now, this is more to do with the what I would say is the nature or the nature of the politics around agriculture in our country. And as the government is in habit of announcing these farm loan waivers, around 50% of the defaulters are willful defaulters, and it is very very difficult to screen out such defaulters in the loan application process. So that is an existential threat to the rural banking scenario in India, because there is a lot of capital deployed in terms of running these banks, but as a matter of asset quality, they are not performing as per expectations. And the third problem I'm trying to focus on here is the regional inequalities in terms of the disbursement of the credit itself. Now, there would be some areas or some geographies where the credit disbursement would be in a full swing, but there would be other areas which would be sort of lackadaisical in terms of the credit disbursement facilities provided by these institutional agencies. Also, the insurance coverage in these areas and the indemnity payments are biased towards such regions. And there are a delay in settlement claims of about 1 year long. So given a peril scenario in India, in any given part of the geography, you will often find that the settlement of those claims against such perils are observed after a year-long effort. So by that time, the will of the farmer to sort of have any respite against such indemnity is lost. So these are the problems which we will try to answer using our approach to institutional credit. So this is the slide which covers our facilitation of institutional credit. We have developed a funnel in which given a loan application, we would be sort of processing it through these series of steps where we are covering our credit appraisal cycle based on the lead management itself, where the lead is coming based on the existing customer or a fresh customer onboarded onto our onboarding application. Now, on the onboarding phase, we would be geotagging the asset of the farmer, as in the land coordinates would be captured, as well as certain farmer specific information about his financial planning or say crop market planning would be captured, socioeconomic data would be captured. That information, once captured, would be run through our risk intelligence platform, which would be using our remote sensing satellite data pipeline, which goes back in time for previous 3 years, and we try to analyze his cropland basis certain productivity factors. For example, how many seasons is he taking in a particular year? How has his crop health been historically? How has his crop nutrition been historically? So these are the problems we are trying to analyze using our risk intelligence platform. Once this is done, and in the disbursement cycle itself, the farm management application can capture various processes the farmer is following, which can then be tied up with the yield analysis as well as the package of practices which the farmer was supposed to follow to get maximum yield. Then comes a portfolio monitoring platform, basically, which gives institutional agencies a hold over how many their lending portfolio, basically, how many farmers they have lended till now, what is their current assessment, how they are performing in terms of their cultivation cycle, how they have historically performed. And then this flows into the LOS LMS, that is the loan origination and loan management system, which will disburse the loan according to the which will filter out the candidates based on these 4 parameters and then disburse the loan accordingly. So, sorry. Yeah. So now I'll just jump over to our AI modules. What are the areas which we are working in? So, so these are the areas typically we are working in, which will facilitate our various platforms, for example, risk intelligence or farm monitoring platforms. and portfolio management applications. So we are working on these problems of farm boundary detection, where we are accurately delineating the farm boundaries, enabling the farmers and agribusinesses to optimize outreach, production, and post-production activities. So this is a major problem which we have identified, the accurate delineation of the farm boundaries to village level. So once given such an farm boundary, we can run crop classification over it on the spectral signatures of the crop, which we have built ourselves using data collection techniques, which we have surveyed in various geographies to understand the lending operations. Then we are coming up with a FRCM risk score, which will talk about the productivity of the farmland historically and give it a score accordingly. We are also working on the market linkage side of the things, where price forecasting methods or automated irrigation and drone image analysis can be used to understand what could be the harvest time and what could be the peak season for the harvest, according to which the marketing can be scheduled. Coming to the farm boundary detection, this is, I'm talking about now the area analytics for Chandan, which we have done. So, so on the left-hand side, you can see the geography of Chandan, which is an obscure landscape in Rajasthan, Jaisalmer, somewhere near Pakistan border. Over here, if you'll see, this is the area of interest on which we have done analysis. And now we have created our pipelines using the AWS satellite data, Sentinel-2 satellite data. So our Sentinel-2 satellite images are stored on AWS S3 repository, from which we have fetched the time series data for doing these farm boundary detection analysis. So on the right-hand side, you can see the algorithm output, what we have been able to manage. So I will tell you something in basic, like what we did. So for the area of interest, we went behind for the Rabi season 2020. We went from October to March. We collected the satellite imagery, over which we ran the NDVI images. We did the band calculation for NDVI images, and then we tried to analyze these in sequence, trying to capture the NDVI standard deviation. So it resulted in a very, what I would say, sorry, I'm not sure whether my slides are not working. So the result was like, if you analyze the peak season in which the vegetation is at peak, that is around December, much of the standard deviation was very visible in different fields, for which we could identify and isolate such field boundaries. We converted such rasters into vectors and tried to overlay it on the map. As a result, this is the output of our algorithm. So now there will be certain further use cases on this. For example, we can overlay the government land survey map over it, which can tie up the survey number against each land to the ownership of the particular land in a particular survey number. And based on this, then we can run the crop classification algorithm as well as the farm score to understand what is the differentiability between different farmlands are. And based on that, we can filter the productive farmlands from the non-productive farmlands. And we can then arrange that information into prospective lead management, which can then go into our loan disbursement pipeline. So now I'm talking about, this slide talks about the crop classification, which we are able to run on around training, like around the survey data points of about 400 fields, on which we have trained our machine learning algorithm to do crop classification. So this is the crop map developed for 4 crops predominant in that area: cumin, gram, isabgol, and mustard. So, so this crop map can further be then introduced by using different techniques during the mid-season to understand what has been grown during the mid-season, so that the portfolio for which the loan has been given can be checked by the institutional agencies. For example, many of the times the lending agencies have faced the problem that they have given a loan for, say, crop X, say crop mustard, to a given farmer, but there is no way to know whether that farmer is actually growing mustard. So he might very well be putting his field empty. or putting it fallow. So that is a major challenge. So these sort of algorithms can be very helpful for the institutional agencies to take decisions on such cases. Now, given the crop classification in the previous slide, we have also run the FRCM risk score, which talks about the historical productivity of the farmlands. All the farms in green mostly have got 2 crop seasons per cycle, whereas those fields in orange perhaps could take only 1 crop season per cycle. This could predominantly be the case in Rajasthan, in this area where the water shortage is an acute problem, and majority of the people who are able to take only 1 crop season per cycle, it has been observed that they are not having borewell water in their farmlands. Though they might have dug borewells, but there is no water, as a result of which they may not be able to take 2 crop seasons per cycle, so per year, sorry. So that is one observation which we found, and which was very much interest to us, because this information then can further be relayed back to the institutional agencies to diversify their loan portfolios. For example, they can think about giving loans for say a drip irrigation system, which is predominantly focused on fertigation or irrigation optimization, fertilizer use efficiency and irrigation use efficiency. So that information also is a very helpful tool in the hands of the farmers, in the hands of the institutional agencies, basically. So the last slide. Yeah. So this is an area analysis of Chandan, which we have done. The fields in the red, which are away from the center location, are towards the desert area, and you can visibly see that the number of crop season per cycle has come down to 0. Whereas in the center, where the population resides, number of crop season cycle has been 2. Like per year, 2 cycles were taken. Now, on those farmlands itself, now we have calculated this average health score, which takes into consideration the NDVI index over a period of last 3 years, and try to categorize them into different levels at which the farms can be seen as having average health score, low, medium, and high. Similar is the case with the nutrition score, where we have taken a particular red edge band, which takes into consideration band number 7 and band number 5 of the Sentinel, which tells you about the historical correlation with the chlorophyll index of the plant, of the crops growing in that area. And on the right-hand side, we have done certain area analytics on Chandan in Rabi 2021, where we could analyze a total area of about 1 lakh hectares, in which we found that the average field size in this area is about 6 hectares, which is very different from the rest of the country, where the average land holding is less than 2 acres. The minimum field size we could detect from our algorithm was about 0.50 hectares. The maximum field size detected was about 24.86 hectares. We classified.
Hello?
Yeah.
Could you please conclude? I mean, your time's up, has been up for a few minutes.
Right. So this is my last slide. And the conclusion, basically, the area of collaboration could be high resolution satellite data sets for field boundary detection use case. That is one. In-season crop health assessment using microwave remote sensing for the Kharif season. Collaboration on developing different techniques to solve the business use cases, which are varied in range pertaining to IoT, drones, and parametric insurance. And documenting the crop phenology at various growth stages for monitoring the crop, so that the yield portfolio can be assessed. So yeah, thank you.
Thank you very much. So now we will keep our questions for after the next talk. So the floor is now to Delphine Thivet, who's from the French Institute in Pondicherry, if she's with us. Yes, she is.
Yeah. Good afternoon, everyone. I'm sorry, I could not hear the question. We are having heavy rains in Pondicherry, and the electricity is, we have power cut. So I just have a power cut, but luckily I am now with you. So I will try to share my PowerPoint. So I will introduce just shortly myself. I am a sociologist. So I am the head of the social department at the French Institute in Pondicherry. And what I would like to share with you is some reflection on what could be the contribution of social science to the field, broader field of digitalization of agriculture and artificial intelligence in agriculture. So the digital revolution in agriculture is, so everywhere we are more and more in agriculture, hearing about precision farming that's going on, smart farming, agriculture 4.0, and this contemporary discourses on agriculture stress a kind of digital revolution being underway in the countryside. And actually, as digital technologies are pervasive in all realms of society, this is also becoming the case in agriculture. So there are benefits and opportunities afforded by agricultural technology and by artificial intelligence. On the social aspect, that is more my concern as a sociologist, it's the enhancing farmers' quality of life in terms of work-life balance is a important argument for farmers to adopt these technologies. And also the difficulty to find some agricultural workers, and so the decrease in external labor cost on farm is one motivation, also very important. And also a way of intensifying on a more towards a more sustainable agriculture can also be very interesting for reducing the environmental impact of farming practices. Yes, I would like to focus on in this presentation on the potential contribution of social scientific perspectives to agriculture, artificial intelligence and agriculture research. So there are unknown impacts in unintended consequences, either positive or negative. And information processing is not good per se. As a historian and social scientist, we know that the lesson of the mechanization, what kind of exclusion effects it could have, especially on women farmers, for instance. So past experience of agriculture and rural modernization everywhere in the world have demonstrated that the technology push without addressing the underlying socioeconomic and ecological dimension risk to generate unwanted outcomes on the social aspect. And so this, so the social science are also considering technology as embedded in social relations. They are like a crystallization of socially organized action, and they are socially shaped, co-created by makers and users, and they can change over time, and they can be also different according to different groups of people, depending on different resources they have, such as knowledge, social capital, etc. So what is interesting for social science is also to see how the use of a new technology in agriculture transforms the farm, changes working practice, of course, so can improve working practices, the work-life balance, but it also shifts the social relations within the field, and it's also may challenge traditional cultural assumption of what does it mean to be a farmer. So beyond the promises of digital agriculture, the question is how technologies are restructuring farming practices and more widely the field of agriculture, how it's changed, what it means to be a farmer, the kind of knowledges and skill it requires, and all the inclusion or exclusion effects on the social dimension. So one aspect of that is to understand, firstly, the adoption, uses and adaptation of these digital technologies on farm. And social scientists have some qualitative methodology trying to see through farmers' eyes. So this helps to understand why farmers do what they do, and to understand how and why they make such farming choices, and in particular, why farmers do or do not engage in certain practices. And this is understood as this enmeshment of farmers in relations of interdependency, both with their material and social environment. So social sciences are more exploring how finally societal structure constrain farmer agency. Farmers are not like autonomous individual with rational choice. They also embed in social norms that defines the characteristic of what it means to be a good farmer. They also enmeshed in the structures such as a powerful food processing industry or supermarket, which impose certain practice to them. And they also follow or not the incentives offered by agricultural policy at the national or international level. And also social actors are having different worldviews and vision. They are, of course, having different resources. They are occupying different positions in society, and all these kind of elements are impacting the access to digital opportunities. The use of new technology can also reset there's a risk existing social asymmetries, depending also on how these social and technical relation can change the connection among technologies and social actors. Another aspect that is interesting for social sciences is also to interrogate the impacts of the deployment of technologies on the farm. And sociologists can, I don't know if you, I hope you can hear me. My net isn't so good. There is an empirical, examination. They will empirically examine how the introduction of new technology affects and restructure working practices, but also the lived experience, tacit knowledge that are not always visible, and the skills of the farmer in relation to human and non-human relations. It will also affect the farm management, the nature, more skilled workers, for instance, and excluding less skilled workers, and the organization of labor will be altered. The farmers' social stature also, how will they be seen by other farmers who are not using this technology, and how it's in creating a new way of being a farmer. And more broadly, the power relations associated with farming, both within the context of a farm, but also between the farm and external actors to the farm. For example, the dependency on technical experts, which can add to the economic cost of the farmers. So to conclude, the idea was to have this kind of maybe of opening the discussion on what kind of interdisciplinary research can be made on conduct on between social science and natural, technical, and life sciences, and how it could be social science could also contribute to outline research agenda and new question also on digitalization, on artificial intelligence, and how researchers from different disciplines could also shed a new light on the direction and condition, and to take into account to develop, test, implement, and scaling these new digital technologies in agriculture. So thank you very much for your attention.
Thank you. So we have time now for questions on both Parag's and Delphine's presentations.
Mr. Parag, may I, sir?
Go ahead.
Actually, Mr. Parag, I have a question.
Yeah.
This is average nutrition index you mentioned somewhere.
Yes, sir.
So how you, calculate this average nutrition index?
Okay, so based on the time series data, sir, like we have analyzed this red edge bands for different fields which we have detected, and we have come up with different thresholds based on the analysis of the range which we have done. And we have then integrated it into a simple formula to come up with different values of the average values of the nutrition index.
So mainly what it contains actually, I mean nitrogen, phosphorus, potash, or something.
Yeah, so there was a correlation in a research paper found that the red edge index was directly proportional to the nitrogen content till 74% R square value. So.
Okay.
Okay, Edmond.
Yes, so thank you very much for the two speakers, very nice speeches. My question is rather for Mr. Rantecker. The first question is, do you work also with World Bank and NABARD? And do you also intervene in the Karnataka state?
Yeah, so our models are domain, like area agnostic. So that is where these pipelines have been created. And we as such are a recent startup. So we don't have a reach till World Bank, but right now we are in a sort of proof of concept phase. For example, the question asked by Mr. K.N. Singh, like what actually constitutes this nutritional index or average nutritional health. So that has still to be verified on the ground. Like we have to collect different data points at which we can say with certainty for different crops, like what it could be. Yeah, so majorly we are not working with the World Bank as of it.
Okay, and the second question is, you talk about the price forecasting. Have you worked on the way to include the ecosystem services by means, for instance, using the soil carbon or the biodiversity? And I just would like to make also a remark on the recent FAO release of a TAPE, which is a tool that can be useful to estimate, let's say, and not only estimate, but to really measure the agroecological approaches at the farm level.
Right.
So do you include the ecosystem services in the price forecasting?
Right. So for us, the price forecast mainly is like we are mainly interested in it because inherently we need to sort of take profit out of the market. So what we are doing is we are directly arranging for the data sets from these mandis, where there are trained mandi agents which are dealing with these commodities, are giving us price updates. On that, we have not still gone for different ecosystem variables into our model. But based on this data alone, like the data coming from the mandi itself, we are trying to analyze certain trigger points based on which we can hold or sell or produce.
Okay.
Yeah.
And a small remark to Delphine. So nice to meet you, Delphine. Edmund Rock is speaking. I think that you never pronounced the term of AI, but rather the digital technology. Yesterday, I asked the same question to several speakers. And the question was how to implement the AI at the farm level, and particularly the smallholder farmers. Hello?
The screen, Delphine's screen is frozen, so maybe she's having...
Yeah, I think there is some trouble, yeah.
Because the social processes going if you know, I could also rely on historical studies on mechanization. What would be the what was going on for adopting this kind of thing from level? I think I reply in the sense that it's requiring specific skills, right? So it's depending on who are the actors targeted by this technology. That's what I wanted to reflect about. I mean, do I reply to your question? Or?
Well, Delphine, it's difficult to hear you because the sound is very choppy. So that's a connection problem. But I think Edmond, that actually Delphine did pronounce the word artificial intelligence many times, but maybe my comment on this is yesterday many of the presentations were insisting on how to make the whatever apps or tools that they produce, how to make them available, how to make them accessible to farmers. And your question, Edmond, is also somehow of that nature. And I don't, I mean, my question maybe to Delphine is, how should a joint project between sociologists like yourself and technologists, quote unquote, whether they're agronomists or AI specialists, how can such a project can be framed? I mean, have you worked already with the sort of, I don't know if that's the right word, but engineers in the field of digitalization of farming? Maybe it was not so clear in today's presentations, and I know you were not able to attend yesterday, but there were a number of people presenting tools that were meant to be used sort of on the field taking various meanings depending on the tools. But and they were, all these people were concerned about how accessible, how usable, how useful their tools would be, and they came from the agronomy or the AI end, and so it would require for sure a collaboration with people knowing how to investigate or interrogate usage. How would that be done? I mean, what should be the framework for such a very interdisciplinary project?
Yes, thank you. I hope my connection is allowing me to reply to this question. Thank you. Yeah, I'm not involved yet in such interdisciplinary research on digitalization and or in artificial intelligence. I am involved in interdisciplinary research on how farmers are changing their practices towards more sustainable practices, and they're in this kind of program in France. I have a research program on agroecology and how. So we are also agronomists and ecologists working with us. But interdisciplinary research takes time, right? So I cannot give a reply about the framework right now. I think it's something we could build, but I am really convinced that the collaboration with between sciences, different kind of sciences, are really enlightening also, as you say, the users, the adoption. Why certain farmers will not go, I mean, for this kind of technology, because it's beyond the technology per se. It's also what it means at the social level that could, and also the resources, not farmers are not abstract people also. They were having different kind of resources. They have gender. There were some agriculture workers also that we didn't talk so much. I mean, I don't know if we, I mean, I didn't talk so much. I cannot say about you because I'm sorry, I could not attend that because of the power cut. But so all these kind of social inequalities of gender, class, also of size of the farm have to be into consideration. And what I was telling in my presentation, sociologists have qualitative methodology trying to explore this kind of use. it's not only it's not only about the technology per se. Yes, was what I was telling. There are some unintended impacts or effects of them, and I hope it could be interesting for other scientists from other fields.
Yeah, very good. So maybe we can keep the follow-up on this discussion for the later part of the session. We have one last speaker. Before we get to that one last speaker, I would also like to formulate a question to Parag, which can be discussed. I don't want him to reply now, but that could be discussed later. You mentioned, Parag, your interest in collaboration on a number of topics, very precise topics. You represent a startup company. So the question of the format or the framework of such collaborations with academic partners is of interest, and it's different than it would be between academic research groups. So that's something that maybe we can discuss in later. That means after 3:30 in Indian time, in the last part of this session. But for now, we can switch over to PC Abhilash, who is at BHU in Varanasi, and will take us about adaptive agricultural practices.
So thank you. My screen is visible?
Yes.
Okay. A very good morning to colleagues from France and a very good afternoon to all Indian colleagues. This is Abhilash from Banaras Hindu University. At the very first, I must admit that I am not an expert and I do not have any kind of expertise in artificial intelligence or machine learning. So I'm here just to explore potential collaboration for utilizing this artificial intelligence in my ongoing research. So currently, we did some preliminary work on adaptive agricultural practices for ensuring rural food security. So I will be presenting basically what the lessons we have learned from the drylands of eastern Uttar Pradesh, that is in Varanasi and nearby states like Mirzapur and some part of Sonabhadra. So the talk I have structured into a different theme like need of adaptive agricultural practices, then the kind of practices employed in Mirzapur district and the lessons we learned and the recommendations and future perspective, especially the future aspects for utilizing this artificial intelligence in agriculture, sustainable agricultural practices. All of you know that the challenge is very tremendous because we have to feed a growing population, and the world population is growing to reach by almost 9.3 billion by the end of the century. But food production, so ensuring the food and nutrition requirement, one of the basic needs, it is very challenging. And in India also, it has been projected that the population is going to become almost 1.7 billion by this 2050. So feeding a growing population is again a challenging task because there are studies that clearly depict that the changing climatic condition can alter the growth, physiology, yield, nutritional quality of agricultural crops, and most importantly, the changing climatic situations can affect the availability of critical resources essential for agriculture. There is an increase, there is a publications, lot of literature that indicates that the increased incidence of pests and diseases, and then the growth and yield of crop itself. So it affects the nutritional quality of agricultural produce itself. So on the one way, we are worried that, to feed the growing population. On the other hand, this changing climatic condition affect the nutritional quality of the produce itself. So the adoption of adaptive and resilient practices that can withstand to all kind of uncertainties and this kind of climatic conditions are very, very imperative for attaining sustainability. And especially when we talk about the sustainable development goal, we have only 10 more years to meet the sustainable development goals. So these adaptive practices and sustainable agricultural practices are directly or indirectly related to almost all 17 sustainable goals. And some of the goals, they are directly related, like no poverty, zero hunger, good health, gender equality, and even the life below water, life on. We cannot imagine then clean water sanitation, responsible consumption, and even good job and economic growth, because agriculture is one of the major livelihood option for most of the people in developing and countries in transition. So in order to reduce the inequality, all these goals are related to agriculture. So the adoption of adaptive practices, resilient practices is very, very need of the hour. So what sort of practices we can call it as adaptive practices? The adaptive practices can be defined as a set of agricultural practices developed by the local farmers to adapt or to adjust to changing socio-economic, ecological and climatic conditions of a particular region without compromising the yield and quality of agricultural produce. So these adaptations are basically meant to or adjust to save the energy or time, labor and money, or maybe to conserve critical resources such as water, biodiversity, and soil nutrients, and most importantly, to adapt or adjust to adversity such as drought, heat, flood, pest, and diseases. So although I am not an expert in this in artificial intelligence, so my query is that my interest is that how we can utilize this technology, because the farmers, they already utilizing their own indigenous and local knowledge. So along with this indigenous and local knowledge, how we can add this artificial knowledge for enhancing all this kind of adaptation potential of such marginal farmers. So with basic objective, we did explore, we studied this nearby village, nearby district for recording various adaptive practices employed by the local farmers, and also to study the social ecological relevance of such practices, and then recommend suitable strategies for scaling up of such practices for sustainable agriculture. And this is study area belong to Mirzapur district, and this 3 blocks we studied in Vindhyan region. The area is dry land, On the other hand, the one block, that is Narayanpur block, we selected from the Mirzapur, that is in middle Janjati plains. There is an excess of water due to Ganga, but on the other region, that is a dry land. So the agriculture that mainly depends on groundwater irrigation, and this is the agroclimatic regions of the study area. I have a lot of pictures, so I have to quickly go through the slides, and we did extensive and regular field work, and these are the major impact, major problems of that area. One is drought, either intermittent or the prolonged drought is one of the major area. So the water is one of the scarce resource. So whatever the practice they are basically employing, that is mainly meant to save water. So one of the practices we noticed that, farmers are very intelligent. So they are just adapting to the changing conditions by selecting or by changing the variety, because all of you know that some of the varieties they are more water intensive, they need more irrigation. So they need more time for cultivation, and their yield is also very less. So gradually they are shifting from such kind of variety, long duration variety, to short duration variety. So the varietal selection, the selection of adaptive or resilient variety, that is one of the strategy to cope up with the condition. And secondly, we have found that rice, for example, this rice wheat cropping is the major dominant cropping in that studied region. So in the rice, what they are practicing double transplantation. Normally, the farmers are raising the nurseries, and then after that, they are directly transplanting into the field. But in this case of double transplantation, they are again transplanting to another field, and from the again, finally, they are transplanting to the field. So by these kind of 2 transplantation and 2 uprooting, they are literally hardening the plant so that they can able to withstand all kind of adverse conditions. And we could able to found that by after this plantation, 2-time plantation, these plants, the yield has been enhanced by substantially. At the same time, there is a negative report of the pest and incidents, because the plants are more resilient than the natural one. So this kind of practices they are doing. Now we are analyzing the socio-ecological impact also. And the introduction of new crop to that region was another strategy to cope up with the changing condition. And banana, all of you know that banana is not a new crop in India, but in some part, especially in the dry land of UP, this is a new crop. So they are introduced banana they are cultivating with the other seasonal crops. So that is one of the strategy to cope up. And then they are using modern irrigation facilities like also. So the research conserving integrated banana plus seasonal vegetable, and then they are using the farm yield manure. So they are using drip irrigations. That is one of the way. So again, they have introduced another crop like falsa, that is Grevia asiatica, that is a medicinal, that is a tree, it is a prunable tree. So the yield, it is once it is planted, the species is there for more than 20 to 25 years. So they can prune, they can use it for multi-purpose aspect. It is edible as well as it is highly medicinal also. So then this kind of practices, they are cultivating along with the seasonal crop. And then the introduction of another crop, that is a seed lemon, that is Citrus elemato. So that is also another innovation by the local farmers. Then they are following apiculture, then the residue retention. All of you know that this, and even some of the farmers, they are progressive and they're using the solar irrigation system. And then the use of wild and climate resilient species, that is another strategy to cope up. They are cultivating some of these wild species along with the modern crop variety. So, and they are highly adaptive, and because they are drought tolerant, they are climate resilient, they need only less water, they need only other kind of, because these plants need only minimal input and care. So the farmers are using these species for intercropping. And then there are several other wild species we have to explore for utilizations, like the wild bean, wing bean, and they're the nutritional. When we analyze the nutritional quality, we could able to found that their nutritional quality is at par with the modern vegetable variety. So if you are using this kind of adaptive species along with the modern species, that is one of the best strategy to avoid rural, ensure rural food security. And then the use of wild legumes by most of the farmers, like soybean, again, the nutritional quality, the vitamin in terms of riboflavin, niacin, all these are excellent. And again, there are several underutilized species, other promising species like wild cucumber, then the sunham, and then the Bacilla, just like Indian spinach. This is a perennial species, and once we have a plant, we can ensure the availability of a leafy item throughout the year. And then the vitamin quality, the mineral quality, it is super than any other modern crop varieties. So coming into the point, so we have noticed that farmers are practicing various kind of, whether adjusting the crop calendar, or they are shifting the variety, or they are introducing new kind of crop. They are adopting diversification strategy. They have different diversification, better irrigation. They are using drip irrigation, sprinkler irrigation, and even solar irrigation. So agroforestry practices are all there. So, but the future prospect is that we have to further explore the local knowledge and indigenous practices of these farmers. And then we have to validate and we have to disseminate this useful technology to other farmers. And most importantly, we have to, how we can use this artificial intelligence for identifying adaptive traits. There are so many wild species are there, the potential agriculturally important wild plants are there. So how we can utilize, how we can identify the promising traits of these plant species and foreseeing their possibility for large scale in the cultivation or intercropping. And then the use of artificial intelligence for sustainable fertigation in dry land, because they are using some of the water intensive crop like banana or other kind of crop. Although in dry land they are cultivating that kind of species because of this kind of innovations only, like drip irrigations and then tube irrigation. So by exploring the potentialities of artificial intelligence, can we suggest some suitable model, including the irrigation plus fertigation model for the farmers? That is my prime concern. And so we are also developing field gene bank at the farmers field and trying to, educate them, trying to cultivate the standard practices for the large scale utilizations. We are also making conferences, seminars, conducting workshops to educate them, to empower them, to utilize for the large scale utilization of this species. Thank you.
Thank you very much. I have a first question about, so just we will take 5 minutes to ask questions on this talk, and then we'll switch over the discussion to the general conclusion or outcome of the whole workshop. So Abhilash, you talk about these farmers in Mirzapur adapting their practices. Is that the general situation? I mean, what percentage of the farmers do all these things, or even some of these things that you mentioned, like new crops or drip irrigation or whatnot?
Only very small percentage, almost 20 to 25% of farmers are. Literally, they are the progressive farmers, yeah.
20% is not insignificant. I really
Yeah,
like.
yeah.
And are they being followed by or imitated by the other farmers?
Yes. That's what, we have developed a farmers field gene bank. I mean, the gene bank of the species at the farmers field itself, so that others can come, they can see. So we are also periodically conducting the meetings so that they can share their experience, the knowledge sharing, so that they can inspire others to come forward.
Other questions to Abhilash? Utpal?
Yeah, Abhilash, nice talk. Thank you so much. Even I know that because in
Yes.
spite of your ill health, you could come. Thank you so much.
Thank you, sir.
So I have a small question, but that has, I mean, the follow-up question of what Delphine told about that. So in while you experimented for experimenting with all these things, did you see these things that say culturally was there any effect? Say for example, you are talking about accepting changes and these things. Maybe 20% what you told that farmers accepted.
Yes.
But did you see? So we are not a social scientist. Very difficult to measure that effect in a standard way. But I mean, just informally, did you see any effect in culturally? They are not.
Yeah, because they are, I mean, accepting that, because now some of the farmers, they know the impact of climate change. They heard about the climate change, and they are anticipating that, okay, this kind of changes is going to affect the yield. And then we also talk about, for example, the latest Lancet report on planet healthy diet, and we educated them that most of the species, they are not having the desired nutrient. Why don't we use this kind of wild species in our for consumption and for other activity? And then again, we try to correlate this kind of with the cultural aspect, like that. For example, that area, most of the wild species, some of the wild species are culturally related. For example, some kind of festival, they are utilizing some specific species for some. So we try to connect with the cultural aspect, like that, these species are for this kind of culture, these species for this kind of festival, tyohar. So in that way also we educated them. But now, for example, the government is providing subsidies for that solar irrigation. So some of the farmers, traditionally they were following that kind of practices only. Now they are ready to go for solar irrigation. And then they are ready to experiment new crops. Traditionally, they cultivated wheat only, but then they have seen that their fellow farmers, they are cultivating banana. So they are trying to cultivate banana in their field. Likewise, they are trying to introduce sweet lemon. So some of them are really, really willing to do such kind of activity.
So
But
is it mostly driven by the revenue they are getting? I mean, the cultural, say for example,
the cultural acceptance is there. And then the demand is also there. For example, nowadays all of you cultivating dragon fruit. Okay, so there is a market for dragon fruit. So nowadays farmers are interested in cultivating market. So if there is a market, then the more farmers will come forward and they will be ready to cultivate more species. So we have to create that also.
Thank you, Abhilash.
Edmond?
Yeah, so I will thank you very much for this very nice presentation. I think that as a scientist, we sometimes forget the local knowledge.
Yes.
We are rather focusing on the globalization, the knowledge globalized. And I think that your talk is very interesting for us, at least for me, to rather focus on the local knowledge. And this local knowledge is very important because when we talk about the climate change, it can be seen worldwide, but the impact is always local. Okay. So we need that. The second point is you just mentioned in the last sentence about the market. My question is about the process used for these foods, so these raw foods coming from the fields. Is it organized also in order for increasing the market, but also to not destroy the the nutrients of the initial foods coming from the fields.
Yes, sir. Yes, sir.
What about the processing of these raw materials?
So processing, I mean, basically they are not selling out. Basically, they are cultivating for they are the subsistence farmers. They are the marginal farmers. They are producing for their own consumption. Right now, they are not marketing. They are not selling out for, because these are the wild variety, and they are basically cultivating for their own home, utilization only.
Okay, very good.
Sir, one small question, if you permit.
Yeah.
One small question, sir.
Yes, sir, please.
What Mr. P.C. Vilas is telling ki whatever evolution has come, they are using for their own purpose. They are not going for marketing or not other things. So how they are being benefited from what they were doing earlier? Because their livelihood was agriculture only, because they're marginal farmer or subsistence farmer. So they were living there. So if what you are telling, if with the introduction of these things, if they are not selling, they're not, their income is not improving. So how, it is helping?
Yes, sir. Yes, sir. I know that you are from UP only, sir. Actually, this is not related to this banana or sweet lemon, and this is related to wild species I was mentioning, like that. For example, Bacilla species is there, wild cucumber is there. So they are cultivating them in their own home garden. And now the others farmers, once they, mentioned, once we showcase the importance of these kind of species, then the other farmers comfort. For example, for the other kind of things like for rice wheat cropping system, now that farmers, they are shifted to the banana-based cultivation system, citrus, Nimu-based cultivation system, and even some of them, for example, the guava-based cultivation system they are cultivating. So they are getting more that the marketing, there is no well-structured markets in that rural area. So they are selling their product as in the same way. As in the case of, the way they are selling the rice, the way they are selling the wheat, they are selling the banana, they are selling other product also. But in the case of wild species, like, that is not large scale cultivation is there. They are cultivating in their home garden.
I agree, Abhilash, I agree. I know that thing. My question is ki now government has a muhim that we have to increase double the farmers' income by 2022.
Yes, sir.
So what is the reality? I wanted to know that, because what you are telling, you are having a lot of intervention, all those things, but they are sustaining their livelihood. So
yes.
See, we are scientists. Our aim is to enhance the income, not
Yes.
we're not doubling. So, but what is the reality there?
For example, in the case of banana farmers, cultivating farmers, so they are getting more benefit than the banana. That's what they are getting more benefit than the rice or wheat cultivation. That's what they started the banana cultivation.
But they are selling banana. But
they are selling their banana. For example, that's what I'm saying.
This question was asked. They are selling. Where is the market and all those things? He asked.
That is the local market only. For there is no well-structured market. For example, selling banana, guava, all other kind of commodity. That is the same way they sell, rice or wheat.
Because you are working to the down-to-the people or ground realty people, so you people are right person to tell, give the feedback that the situation what we are foreseeing for beyond 2022, we have to do a lot of, I think.
And one more thing is that you mentioned that you asked me about the profit. For example, apart from selling the banana, they are getting suckers. They can sell the suckers. By that way also they are getting money.
That's why I know that they are benefited. But you told me they are not selling. That's why.
Yeah. Sorry. Selling for I thought that it is only for the wild variety like a Bacilla, that kind of little edibles. Yeah.
Prosperity is coming.
Yes.
Okay.
Yes, sir.
Get this short because it's a little specialized for the varied audience. So we will switch over to a more general discussion, but there's a request from the platform that we all turn on our video cameras and that the group picture will be made by somebody. I don't know who, but somebody from the platform will do that. Thank you. Shivani, I think, is going to do that. So everybody who can turn on their camera, please do that. Not everybody can. Yes. Right. Okay, it will be, Shivani, if you want to make your photo now, it will be a partly abstract photo. There will be names somewhere, but that's it. Please let me know when you're done and we will resume. Okay, so Shivani says we're done. That's perfect. Good. So now, it's up to you to keep your camera on or not. And so I think I mentioned this in the very opening of the workshop. Utpal and I have been tasked with providing the organizers, which means the CEFIPRA and the French Institute in India, with recommendations. Now, recommendations is a very vague term, but I was told that this would be not empty, not vacuous, and that we have a chance here of having an impact on the keywords of future calls for projects at CEFIPRA or other funding agencies, but CEFIPRA would be the main one. So this is, whereas in some sense it's an artificial, not intelligent, but just artificial exercise. Maybe this time it can have a useful impact. So I think we have at least two sorts of things we can be discussing, and they will be not clearly separated, but one is the scientific nature of challenges to be overcome. So what are the bottlenecks? What are the questions that are really urgent or most important in that general field of AI for sustainable agriculture? And that's extremely vast, extremely wide. And it's, all fields are relevant. And the other, because this has to be future joint projects between French and Indian teams. So what are the modes of collaborations, Indo-French collaboration, that we should want to see supported? And for meaning, I mean, both for the challenges to be overcome and for the modes of collaboration, we have to keep in mind that this is meant to be not science in general, but Indo-French projects. So hopefully there should be teams in France and teams in India who would be likely at least to pick up these challenges and propose projects. So maybe some of you already have thought about this and can indicate some directions. Edmond.
Yes, I would like just to make a small comment about the title of this event or this session, Artificial Intelligence and Agriculture. And I think that this keyword of agriculture, for me at least, should be seen through, particularly in the cooperation aspect, so should be seen through the ICAR in India and INRAE and CIRAD in France. I think that these institutions can be really involved in such a cooperation. And the artificial intelligence can be seen also as one discipline. And I think that several talks insisted on the point that the future of the application of AI in agriculture should be interdisciplinary. So we listen, for instance, to Delphine, the social sciences. We listen also to other people involved, not directly, but indirectly, on how to use the AI in agriculture. So the two talks this morning. So taken together, I think that perhaps if we have to make a report, Pascal, so perhaps we can alert, let's say, CEFIPRA, that these agricultural sciences should be also inside the keywords or inside the calls made by CEFIPRA and the French embassy. Thank you.
So you're saying I shouldn't have done this? It should have been INRAE.
No, it's not should, but I think that we have to include the main institutions working on agriculture. And I also would like to mention, one sentence coming from one of the speakers by saying that several SDGs are linked to agriculture issues. So I think that besides the technology by itself, which is very, very interesting and very important, I think that if we want to reach the SDGs, agriculture should be now seen as one of the most important keywords in all the approaches, particularly in the interdisciplinary or transdisciplinary approaches.
Right. I think you're quite right. Of course, that INRAE and the analog departments and research centers and networks in India should be central to this discussion. And in fact, the speakers in the two different sessions were so on the French side from INRAE, from CIRAD, and so on. So of course that's very important. I think you mentioned yesterday that you're in charge of international relations and especially the relations with India at INRAE. So you are in a very privileged position to influence both INRAE's policy and the CEFIPRA through, I mean, the pull, the influence that an institution, that an organism like INRAE has far exceeds what little I can do, or even what a diplomatic corps, the diplomatic posting can do. But that's, of course, these are very important considerations. Abhishek.
Okay, so I just have a sort of a comment is that while ICAR and the French counterpart has important role to play, there are other institutions and maybe other scientists who are working on many corresponding domains, which could also contribute towards the main goal of doing sustainable agriculture. So, for example, in ISI we have a strong team for artificial intelligence. We have a little bit background in agriculture as well. We also can join hands with French counterparts there, so that we can build a certain aspect. It may not be crop forecasting, but there are many other aspects, like, for example, specific disease identification part, and we can tackle local problems that sometimes can be better served with groups that are not really directly related to ICAR, maybe some other groups as well. I think that would broaden the scope. Thank you.
I agree, obviously.
Very good. Pierre?
Thank you very much. So I would like to share some potential subject of interest that could be promoted. So I let all the participants to define if this can be appropriate or not, but we discussed quite intensively yesterday, I think, about the interest to have a solution that facilitate sharing of training data and or models And so I think this is a way to mutualize previous research results and to progress much more quickly in a context of a quite broad network of actors, such as the people here in the workshop. So I think there's any initiative that could help to facilitate, increase visibility, accelerate access to training data, I think will be something useful for all of us. We did not, I think, mention too much, but this is something that is quite important in the AI community, and not specifically applied to agriculture, but the fact that there is some platform which allows to make a benchmark and comparison on the same training data set to compare the different strategy solution and to have an appropriate evaluation, not only about the precision, but also about the speed, the transferability of such solution. So a second point is for me, the promotion and support of benchmark that are specifically dedicated to the experimentation of AI in agriculture with particular tasks. Several of us mentioned the work that we conduct on plant disease identification. There is a weed species detection, spicle counting task, for example. So these are few examples that could be mentioned. And the third and last point that I would like to mention is the fact that AI is quite intensive consuming about computational resource. And we discuss the fact that in order to provide a broader access to research results and AI-based computational services, we have to offer or find a way to provide this type of research results in a quite low-tech context. And I think that subjects that could increase the research activity on how to train and how to have a good balance between high performance models with low computational resources, and why not in offline context. So this is in order to transfer some kind of capacity of automated detection, counting, and task in a non-connected context, such as with an embedded model on an offline sensor, could be something that I think can be useful in this collaboration, because in agriculture, we cannot always access to a quite intense bandwidth, good internet connection. This is feasible for some type of actors in agricultural activities, but most of them, I think in India, don't have these facilities. And so this could be a subject that could be of interest, I think. Thank you, and sorry if I was too long.
No, very good, very good. So this was indeed something that I had noted after yesterday, that this notion of sharing data, sharing models, sharing ontologies, sharing annotated banks of videos or images that can be used freely by scientists to train their models, to benchmark their results. That's something that's in the spirit of the times, open science, and it's something that is beginning to exist. I mean, several of the speakers spoke of portals or platforms that they have access to, that they participate in France, in the EU, in Australia. I remember somebody mentioned, and so it would be at least important to have some kind of map of where those, not necessarily where physically, but where those resources are, who can access them. Like Pascal, I think, mentioned data.inrae.fr. This presumably can be used by everybody, including researchers in India. So that sort of thing would be very good. And another thing which echoes what you just said very precisely about low tech and low bandwidth usages. Many of the speakers yesterday talked about developing as part of their projects mobile apps, either for data collection on species identification, for instance, or data collection on the field. Some sort of either citizen science or just farmers entering their own data. And also for data processing. So that's I'm sure plays a very big role in the acceptability or even in the usability of these AI tools. Depending on the ergonomy, on the resources required, that will change also who gets to use them and who doesn't. So that's all related with things that were mentioned by several people, both from the technical and from the social scientist point of view. So these are, I think, common features of many of the interventions. Saikat, go ahead and you raise your hand. Dr. Saikat Kumarashoma, you raised your hand. Please unmute yourself.
Okay, sir. Sir, my concern is because I was talking about food grain production, and we have not come out to.
Dr. Singh?
Yes, sir.
Somebody else raised their hand.
Okay.
As you can see. And that person is not muted at the moment, so I don't know if that's voluntary. Shaivani or Streamitech, can you unmute Dr. Saikat Kumarashoma?
Yes, sir.
Okay. Can you do it? You cannot? Okay, then while we wait on this, Dr. Singh, please resume.
So my concern is to forecast the crop yield at district level or block level. So, I mean, there are many immediate technology like drone technology, remote sensing technology, hypersensitive, many technologies are coming, but accuracy is a problem. So that's why we are thinking if, I mean, I don't know in how France, they are using the technology to give the, I mean, a forecast of food production. So we have used this machine learning techniques using the weather variables to forecast the crop yield at least up to district level. So we want to come to block level. So if any collaboration or any, I mean, help is done by the expert of both the countries, that will be helpful. And ICR will be happy to, I mean, collaborate with the, I mean, other countries. Thank you, sir.
So this is an interesting transition to this question of how to collaborate. Because several people have said, we're willing to collaborate, both from India and others. Well, that's very good. That's a good, essential starting point. But that's not precise. This is like that. This is like nothing. Because to collaborate, how? So some people have said, oh, if we could organize exchanges of visits, internship for our students, that would be great. Okay. But which funding agency is going to give us that sort of thing? As far as I know, none. CEFIPRA wants scientific projects which can certainly involve students. It's probably even encouraged, but the main actors are the principal investigators, and so it's not a part of the training of students sort of thing. It has to be a research project. So we have to say something more than we're willing to send our students as interns. so that's the next thing. So we have to have point-to-point contacts. This team, I mean, ICR, INRAE, whoever, very good, but it's not ICR and INRAE. Those two can make a MOU between them and have their own call for projects, and that would be absolutely great. But from the point of view of CEFIPRA, it's Professor this, Dr. that in India, and another Professor this, Dr. that in France, and a few people around them that have a scientific content project, and that's what we want to encourage. That's what CEFIPRA is going to fund. So what we would like to do is tell CEFIPRA, please put in these keywords, precise keywords, relatively precise keywords, so that there can be teams, pairs of teams, France and India, that will reply with solid projects on these teams. Kavita in the chat is saying that these funds will fund something beside travel. Absolutely. For one thing, they can even fund PhD students. Can they fund internships? I don't know. But they can fund travel and internships. They're not too extraordinarily expensive. I mean, if institutions really want them to happen, they will. If institutions don't want to pay for them, of course, that's a different thing. So this is really what we need to go a little further than we're willing to participate. And I completely understand that the groups in France and in India who are meeting here today and yesterday, by and large, don't know each other. So they're not going to come up with a great project by tonight. But what are the keywords that should be put forward? I mean, I think I may be completely wrong, but I think that keywords such as yield estimates are much too precise. And that computer vision for agriculture may be of the right granularity. Utpal, do you mostly agree with that, or how do you view it?
Yes, sure. And I have also written some points, so probably I will make a small presentation for 5-6 minutes.
Okay, very good. So I see that Dr. Saikat Kumarshan is ready to share his thoughts.
Yeah. So am I audible?
Yes.
Yeah. Good afternoon. And first of all, thank you to the chairs for very smoothly conducting this program. So I have just two small policy level suggestions for CEFIPRA. So maybe you can just focus on a sustainable collaboration front. So already there has been some researchers who have executed such projects, maybe some small mobility support or something to extend the collaboration as a long-term sustainable collaboration. So that will certainly handshaking and networking among the countries. And the second is to launch some special calls. So some special calls as this webinar is going on, maybe identified. So this was the trend with CEFIPRA 4 or 5 years back, but of late, it's only the collaborative research and the industrial project track, so which encompasses a very wide domain of areas. So if we can bottle down on some specific areas and give improved emphasis, so that will certainly strengthen the bridges between these two nations. Thank you.
Yes, you're quite right. Before Utpal tells us his points, I would like to maybe mention the context where this, maybe it's also in part an answer to Edmond's veiled criticism. The context for this workshop, from what I understand, I am not CEFIPRA, I'm not speaking for CEFIPRA, but this is what I understand. CEFIPRA covers most or all of the so-called hard sciences. I think agricultural sciences are covered by CEFIPRA, have been for decades. And so those fields are always welcome for grant applications. However, for a variety of reasons, CEFIPRA wanted to put an accent, an emphasis on AI. Part of those reasons is because they had not had many projects support in this field. And another set of reasons was that both governments, French and Indian government, several times over, insisted that AI should be a point of focus of the French collaboration. And so CEFIPRA, being funded by those two governments, had some targeted calls for AI and put AI up front in this particular knowledge summit. And then this AI workshop split into 3 parallel workshops, which have AI in common: mathematical foundations for AI, AI and health, AI and sustainable agriculture. And so this is why, maybe unfortunately, AI is there in the title, even though from an agronomist's perspective, it is only just a tool towards a different or higher purpose, which I completely understand. I'm ready to agree, but this is why it is like that. And so yeah, AI is AI in the broadest sense, AI, ML, digital, whatever, anything. I mean, it's not a restrictive definition, but it's not, food security as first and foremost, for instance. So this is just to remind everybody of why things are framed the way they are. They could have been framed differently, but this is how they are. So Utpal, please.
Yeah. So I share my screen. Okay. So maybe basically I would request comments on these points from the speakers and participants. The first thing already, say Pierre and yesterday also, Pierre mentioned today and yesterday also we discussed about this, that is it possible to formulate a forum, maybe under CEFIPRA or some other Indo-French organization, where we can share data and some of the tools what we have developed. This is required for many different purposes. So for example, to facilitate others' research, they need not generate the same kind of data or the same tools. Say for example, Kavita already developed something CNN-based counting tools, and also our French colleague. So in fact, if I want to do the same research and if I develop this is a kind of reinventing the wheel. So if we can avoid that kind of situation. Second, sometimes since it is more like say AI or machine learning for healthcare, the similar situation is also here. So you have developed some tools, say for example, which is tested given that French climatic condition and soil condition. Now it may happen that same tool, which is quite giving high performance for French situation, may not be suitable for Indian condition, because we have very different climatic condition, soil condition, everything is different. So sometimes if some tool is available, then for the similar kind of problem, we can test it in Indian context. So this cross validation of these models would be another interesting point. So, and definitely one objective, as Pascal nicely explained, that finding out bilateral projects, and even CEFIPRA helps consortium projects, funds consortium projects where we can have industry partners. Say, so it is basically 2+2. So one academic partner and industry partner in India, as well as a similar combination from France. So this is also possible. So in that case, we would request you for Indian speakers as well as French speakers. So during this 2 days workshop, if you have identified some group, they are doing the same kind of research where you have interest, and you can take together, you can take it forward, or complementary expertise. So for example, what Ovilas presented today, he nicely mentioned that, okay, AI component is not there, But if any group from France is interested that, okay, some of the AI things can be exercised given this problem, then that can develop a very nice project. Also, say cultural issues, if Delphine can find some common interest with what Obilas is doing in UP, Uttar Pradesh, that probably in a controlled environment, both things can be exercised, that scientific thing as well as social issues. So bilateral projects, if we can find out some, and then I think maybe I would look for your comments that can we identify at least 1 or 2 projects from industry or practitioners so that lab to market, we can test this, that whatever we are designing, the lab condition, is it possible to reach the small scale farmers, and is it possible to take it to the market? So for this, we need, it will be better if the problem comes from industry, because they know that what is the requirement right now, what are the components where state-of-the-art methods can be used, or some portions that require further research. Okay, and during so my 4th point is during this 2 days of workshop, we did not discuss much about 2 AI issues, definitely robustness and explainability, because in some of the use cases are very much mission critical. So the reason that healthcare community sometimes they are very much skeptical about accepting AI products, the same situation can happen in agricultural research also. Say for example, say yesterday Hugo demonstrated a very nice system, but if it happens that AI say goes mad and picking up trees, and you will lose enormous amount of money just because of that problem in that AI module, right? So how to test robustness, and though it is very difficult to explain the term that what do we mean by explainability in AI, though I mean AI community, we are till searching that the definition, what do you want to mean by explainability of AI systems. But for agricultural problems, if we can define, say for example, we have say ontology, we have very good rule based, and those are already proved that quite strong. Now, is it possible to do some kind of research where say AI decision can be explained through human interpretable rules, so that say domain experts, they have been relying on these rules on ontologies for many years, right? So for such and probably you can add more research issues that for AI for agriculture, what could be the other research issues? I could think of these 2 could be pertinent. And I agree with Kobita and Delphine that they have mentioned in the chat that so can we formulate at least 1 research project where these sociological issues, because whatever we are discussing, deciding, sitting under an say air-conditioned room, but could be may not have that much meaning in the real situation where cultural effects come into play and many other issues. So how to design that kind of say 1 module that, okay, we'll do research, but the cultural effect or sociological effect of this kind of research on the say farmers community, that will be definitely very exciting project. And probably if I can identify 1 more say direction, say iCare, they have many students. In fact, Abhishek already mentioned that they have a very nice course in ISI Giridih. And in India, we have many institutes. They are teaching agriculture. Similarly, I'm sure that France, they have similar organizations, research institutes teaching schools. So since CIFIPA, they support student exchange and student involvement, can we formulate at least a project under CIFIPA? So these are the points I mentioned, and I invite your comments on this. Thank you very much.
Delphine? Oh no, Delphine was not raising her hand, but approving. Thanks, Utpal. So that was a very useful and clear. I think it's again. I am a little unsure that CEFIPRA would ever want to support a project that is about student mobility. Student mobility is great, but it's not their.
No, Pascal, they have a scheme. Even they fund exchange of master students also. I have seen under CEFIPRA. They have a scheme.
But the Raman Charpak?
Yeah, Raman Charpak is one of them. Yeah, yeah.
Okay. Yeah. So that one is good. It's unfortunately not enough scholarships are given. We have with my own collaboration with
in fact, Pascal, I see Dr. Amitabh Das is here. So Dr. Das, will you make a comment on this, that CEFIPRA is funding student exchange?
Are you asking me?
Absolutely.
Yes, please.
Yeah, so basically there is a committee in CEFIPRA, so they are the decision makers. But from our side, what we can tell that there is a scholarship called Raman Charpak Scholarship. And if any Indian student who is actually enrolled in any Indian institute doing his PhD, a part of his thesis work, if he's interested to do abroad, especially in France, definitely then he has to identify a co-host in that case. And in that case, both Indian and the French scientists, they have to submit a joint project. And Raman Charpak Scholarship will allow that Indian scientist, that Indian PhD student, to carry out his research for a period of 3 months or so in France. So that way we can help them in Raman Charpak Scholarship. Also, another scholarship is there, that is Eiffel Scholarship, which is also applicable for engineering students, and they can go for PhD, and the amount of stipend is close to 1,200 euros per month. And the air ticket, that is to and fro, the return ticket is sponsored by the Eiffel Committee. But in case of Eiffel Scholarship, it's not the students who can directly apply. It's basically the university where the student is willing to do his PhD. That professor, that French professor, has to apply on his behalf to the Eiffel Committee. So these are the two scholarships available. Apart from that, what we can do actually, we have, we at French Institute in India, we maintain a database of French professors, especially the research labs, and we have got a good number of contacts. So in case you have any specific project, definitely we will be really, ready to help out Indian students and professors. And that's what is our job is, basically to ensure that Indian professors are put in touch with the French professors and vice versa. So do not hesitate to contact me. I will send my contact details in the chat box. And in fact, we have done it quite a few times in the northeast part of India, inviting French professors for a seminar. In ISI also, I guess, Dr. Garen, I have met you during that
right. Yeah.
visit.
I remember.
Yeah, natural language processing, a French lady visited when you were taking a class. So we'll be more than happy to do this kind of collaborative activities. Thank you.
Dr. Kunal, will you have any comment on this from CEFIPRA? Dr. Kunal, am I audible? That on students visit? Okay, Pascal, please go ahead.
No, it's I forget where I was stopping, but it's great to have had this clarification on what is available for student mobility. So these Raman Charpak fellowships that are student-centered, the students apply. Of course, they have to have support from the host lab, and then the other mentioned by Amitabh Das, that is more research group centered. So joint group of French and Indian researchers apply on behalf of a student. But that is okay. So that exists. I'm afraid it doesn't exist in huge quantities, but still, that's really good. But I think our focus should be still on the keywords for, as you did, Utpal, on the key ideas, at least before the keywords, of what joint projects could be, or what we would like targeted programs to be, and what we would like them to be focused. Edmond?
I would like to make a request to Uptal and Pascal. So is it possible for all the participants to have the email addresses of all the people for the 2 days? So in order for exchange and to, okay?
Yeah, sure.
Thank you.
Much. Yeah.
At least of the speakers, we have that. There are other participants who were not speakers, and I'm not entirely sure we have their email addresses, but for the speakers, it's easy.
Okay, so can we ask to the participants also to, let's say, to let our own address to Uptal or Pascal in order for them to make this network?
Yeah, that will be great. Yeah.
Okay, so I will send mine as soon as possible. Thank you.
That and yes, again, those who were speakers don't need to do that. We have their address, of course, already. So, any other comments or suggestions? I had an offline, a private online discussion with one of the participants about who's saying we would like to have targeted calls from CEFIPRA or whoever on those topics, whatever those topics can be.
Right.
This is exactly what we're working towards, right? This is what we're working towards is what should be these targeted calls. What are the targets we want to be still. So in some sense, it's not so difficult to produce those target keywords, because as far as AI goes, there is something about data, and we've discussed this already, data collection, data annotation, data sharing, so that's a whole chapter. There's something about analysis of data which can be, I mean, a large chapter is computer vision. Traditionally, long before we were so obsessed with AI, computer vision was already a big thing. And so computer vision is central, and this was illustrated in a number of the presentations. So some things should revolve around that. And of course, computer vision is enormously enhanced by ML techniques and more generally. Then there's a question of extending that to heterogeneous data, like crossing images with remote sensing on various other channels than the night, and then maybe on completely different sort of data, like weather data, for instance. And then there's, like, I would say, the purely data-centered, the non-visual data, like when it deals with weather, but when it deals with the economics. So. And then there is the different chapter of acceptability or impact, which has to involve social sciences. And is can be sort of self-standing, or can be in collaboration with projects which aim at more direct deployment on the field. So more sort of downstream, more advanced, ready-to-use projects, or more upstream, abstract, pre-deployment research projects. So maybe my question at this point is, when I say that, what am I forgetting? What main chapters or keywords should be added to this these few sets of keywords? And then another parallel question then is, a lot of people here have expressed their interest. Kavita just said it, did it in the chat right now, have expressed their interest in collaboration and being more specific about what sort of topic they would be particularly interested in. So that's great. What are our tools to keep in touch, to even remain informed of what the targeted goals will be, if ever there are any, from CEFIPRA? Because if ever it happens, I think it will be in a year or so. So in a year, we'll all have done many other things in the meantime. So is there something that we can do among ourselves to, is there any need for something to keep in touch and share info on, even, we have some money to take in some interns, please send us your best students, or that sort of thing. And we don't have to do this completely on our own. I mean, there are, Edmond has been very active in this discussion, and he is is very influential at INRAE. So large network organizations are, network in the sense of they're present all over the territory in France. Organizations like INRAE or INRIA or CNRS, for one thing, they can have their own calls for projects, of course, and their own sources of funding, but they can also play a role in centralizing, or organizing a network. I think the word's been used in some little different field, and also in an earlier thing we did together with UTPAL to develop an ecosystem of researchers in France and in India who have an interest in Indo-French collaboration, who share in scientific interests, of course, and who can share data and tools, but who can also share information about the projects that they'd like to be in, or the calls for projects that happen in their country, but that can include partners from the other country. For instance, EU projects can include third-party participants, so that can be something of interest, and maybe the info comes through the EU-based partners, and also much more modest things like internships. Internship proposals that are sent usually in technical mailing lists, but maybe they can be shared here. So Edmond is reacting and is in the chat, and he says that there's a hashtag Digitag website. That we should have a look at. So let me go on that Digitag.
Yes, I react by sending to everybody this website because in INRAE, but there is a network not only INRAE, particularly associated with INRIA, and all the people inside this very big network are working on artificial intelligence related with agriculture. I think that if I have to, I will try on the proposal of Pascal to try to make this network, but surely I will ask the people working there, and they have also a specific international office inside this network of #Digitag. So perhaps I could make a link with these people and to program or to organize a network on or with all the people working and discussing today in that TS3 event.
Just I can add some information about Digitag. I am a member of Digitag. It's maybe around 400 researchers for digital agriculture. It's a lot of researchers are based here in Montpellier.
Yeah, I know.
If you want more information, you can contact me or contact Véronique Bellon-Morel, but I can.
Okay, so that's I'm sure very useful. So just to clarify, can anybody join Digitag, like Utpal, for instance, or whoever was participating in today's workshop? Or is it only for INRAE and INRIA?
Not exactly. it's a little bit
That's why
a little bit complex, but a lot of part maybe INRAE, also INRIA, also Montpellier University, and some unit in Toulouse and Rennes.
Okay, so it's actually closed.
Yes.
Okay, so then we cannot join it.
No, not really.
It is.
It's because but there is some still some call for collaboration. It could be nice. I think we can develop a collaboration with India and in the frame of Digitag.
That would be great. I asked because I know that some of the organisms behind Digitag are usually, they love being closed, so they are closed in this case as well. So it is. That means I couldn't join, Utpal couldn't join, but maybe there is a mailing list or a newsletter from #Digitag that would contain useful information, provided it's in English, for Indian colleagues about maybe calls for projects and that sort of thing. I don't know. That may be a path to use it, right? I mean, to usefulness in this context.
Yeah.
Because I think this is the thing, we are happy to be talking about these things and thinking of collaboration today and yesterday, and then next week we're going to be in something different, and then we can't all be checking in different mailing addresses or websites all the time. So that's the thing. Is there any sense in organizing a mailing list? There's nothing easier, but will anybody post anything on that mailing list is a different matter. Because I think in France there are lots of different research organizations and schools. And they're somewhat organized in national networks, but several different national networks which don't always communicate very well. And I think in India, it's the same, right? I mean, is there I don't know, a network of all computer scientists or a network of all agronomists? So So we lack tools to share information.
Right.
I don't know whether it's all right as it is, or whether it could even be a project to fabricate such a portal or whatever. Maybe Indo-French is a little too specialized for such a portal. All right, any more comments? So Utpal and I are going to share the list of email addresses that we have, meaning all the speakers and those who have sent us their email addresses. We'll share them to the same list, of course. And we can probably share also a summary of the recommendations that we will send to CEFIPRA and the French Institute in India. And please use these email addresses to continue conversations or elaborate projects. If you found some groups of interest, even I would say even without waiting for an official call for project, because I'm rather optimistic that there will be such calls for projects. I don't know when exactly, but when they come, they usually come with the deadline in next 3 weeks. So better the project be ready beforehand. Edmond, you raise your hand.
Yeah, just to ask you if this report of recommendation to CEFIPRA could be available for the participants in order for us to have an idea on what you recommended to this.
I said we would share it to the people whose email addresses.
Okay, and the second point is I would like to remind what I said yesterday. So actually I will move to India. So I will be in Bangalore from 11th of December for 2 years. So if some people want to meet me, so I will be very happy to discuss and to go further on this aspect, but also on other aspects of agriculture issues and scientific solving of these issues. Thank you for Utpal and Pascal also for this organization. I really appreciate it. Thank you.
Thank you.
Okay, is this it? No more additions to the future recommendations?
Je serais tout à fait content de voir Delphine très bientôt à Pondichéry. Donc, it's a personal message.
But shared with all. Very good, very good. Yeah, Edmond, you mentioned, maybe you can repeat what you said yesterday, that you will be heading a living lab.
Yeah.
At IISc Bangalore.
Exactly. So actually, this is a living lab. The title is Climate Smart and Nutrition Sensitive Food System. This is a program that was presented in the KS1, so the Knowledge Summit 1 in Delhi, as a roadmap in Indo-French cooperation in agricultural area. And we want to develop this program in Karnataka for several reasons. And this program is supported, the two PIs, principal investigators are Philippe Mauguin, the CEO of INRAE, and Mr. Girish Sohani, the former president of BAIF, which is, I suppose, very well-known NGO in India.
Super. Very good. Utpal, any last comments?
No, it's okay. We had wonderful experience during these 2 days. So I would extend my thanks to all the speakers and participants. And in fact, Indian speakers, in fact, whomever I approached and everybody agreed to speak, that's a great thing that happened. So let's see, look forward that what are the outcomes of this workshop, and we are hopeful. So thank you so much, and merci beaucoup, my French colleagues.
Thank you very
Thank
much.
you, everybody.
Thanks a lot to everyone.
Yeah,
Thank you. We'll
Organizer in particular.
Utpal, should we meet separately to discuss this?
Yep, we can have a Google Meet and finish this.
Okay.
Okay.
Will you?
Okay. Bye bye. Take care. And Happy New Year in advance.
It's a good thing to be ready.